This is part 3 of the Chapter 1 lecture notes. We were talking about negative feedback as a way to regulate homeostasis. And this is an image of the example that we used with the thermostat in the house. So basically what you have in negative feedback is the stimulus is either going to increase or decrease. It's going to either be an increase or a decrease with the set point, from the set point. So in this case, the stimulus is the thermometer determines that the temperature has raised, so it's become too hot in the house. And that information is sent from the thermometer, the receptor or the thermometer, to the thermostat, which is the control center. And the thermostat sends the commands to the effector, in this case, which is the air conditioner, and it is going to oppose or negate the stimulus. It's going to lower, whereas the stimulus was a higher temperature than the set point, the air conditioner is going to lower the temperature until it's back to the set point. And therefore we say homeostasis is restored. So, and I'll just do number 9. What happens to the body when homeostasis breaks down is that illness and disease can result. Negative feedback is described more on this page. We will talk about, I'm not going to go over every single thing because we just did. So we will talk about how the body regulates body temperature. Thermoregulation is an example of where we use negative feedback, or the body uses negative feedback to regulate body temperature. So the reason we call it negative feedback is when just like with the thermostat in the house, when the body temperature is too high, the body has ways to respond that lower the temperature. So it negates or opposes the original stimulus. When the body temperature is too low, then the responses raise the body temperature. So very similar to the thermostat in our house. And the effectors are going to be sweat glands and smooth muscle in the blood vessels that allow the blood vessels to dilate or constrict. So if we look at the body temperature is high, we have sensors in our body that receptors that sensory receptors is what they're called, that detect temperature. They're called thermoreceptors, and some are located in the skin. And the control center in the brain is actually the hypothalamus, but that's the control center where the information about the body temperature goes, where it's received is the control center in the brain. And the control center is going to send a signal to the sweat glands and the smooth muscle in your blood vessels. And what the sweat glands are going to do is, and these are both, the sweat glands and the smooth muscle are going to act as effectors. And what the sweat glands are going to do is increase sweating. That's going to help the body cool. And then the smooth muscle is going to dilate. It's going to allow the blood vessels to dilate. And because the smooth muscle is found in the walls of the blood vessels. And so the blood vessels are going to dilate, and that's going to increase blood flow to the surface of the skin where heat is released into the environment. Heat is radiated from the surface of the skin into the environment. And these things are going to cause the temperature, the body temperature, to lower. And so what happens when the body temperature is too low is the control center, which we said was the brain, is going to cause the sweat glands to decrease their activity. The smooth muscle in the blood vessels now is going to cause the blood vessels to constrict, and that will kind of hold in heat. It will decrease blood flow and kind of hold in heat, decrease the heat loss to the environment. And then the skeletal muscles will come in to play sometimes. You may notice when you get cold that you shiver. That's your skeletal muscles, and that shivering will also produce heat. So the body temperature will be raised back up to a normal level. And you can take a look at this illustration here on your own, but it just illustrates the same thing. I'll point out a couple of things. The receptors are the body's temperature sensors. Those are the receptors. Because you may be asked, like you may be given an example and asked to tell if it's the receptor, the control center, or the effector. So in maintaining body temperature, the receptors are thermoreceptors or thermoceptors. They're the body's temperature sensors. They send information to the brain, the hypothalamus in the brain, but the brain is fine, and the brain acts as the control center. The thermoregulatory center in the brain is actually in the hypothalamus. So just for your information. And so the control center sends commands to effectors, which are going to be the smooth muscle in your blood vessels, your sweat glands, and in the case of if your temperature is too cold, your body temperature is too cold, it's going to send information to the skeletal muscle, would be effectors as well. So just make sure that you know the different examples and whether they are receptors, control center, or effectors. Okay? Positive feedback only happens in a few situations. Blood clotting is an example of positive feedback. Labor and delivery during childbirth is another example of positive feedback. And what happens in positive feedback is that whatever the stimulus would be is going to be reinforced or exaggerated. It's going to be enhanced or increased rather than negated or opposed. So in blood clotting, for example, you're bleeding, so there's a break in your blood vessel walls. There's damage, and so the first thing that's going to happen is blood clotting is going to begin. So a simple way to say this is once blood clotting begins, once the process begins, it increases and increases and increases until you have a blood clot. The process doesn't get less, it gets stronger, okay? So first thing that happens in blood clotting is chemicals start chain reactions. What you're seeing here are platelets that are coming in to form a plug. Sorry, that's supposed to be an arrow. They're coming in to form a plug to block the area of injury, the area where the tissue is torn. So platelets or cell fragments and dissolved proteins begin to form a clot. And once that process starts, chemicals are released. These chemicals increase the clotting. And then as the clotting increases, there's more chemicals released. So everything's just increasing, increasing, increasing. More chemicals, more clotting. More chemicals, more clotting. Until you finally have a blood clot. And it's the same thing with labor, okay? So once the contractions begin, if any of you have ever been in labor, you can relate to this a little more, but from what I understand, once the contractions begin, they don't get weaker, they get stronger. And then the stronger contractions cause the release of chemicals, which increase the contractions. Oxytocin and other chemicals that increase the contractions, and the contractions increase until the baby is born. So this is another example of positive feedback. And we'll just do number 11. Why is positive feedback helpful in blood clotting but unsuitable for regulating body temperature? Because positive feedback increases the stimulus. So if the stimulus is the blood has started to clot, we want that to be increased until the clot forms. But if the stimulus is a fever, which is a high body temperature, we do not want that to increase. If it were to increase, the process would end in death. Okay, and now we're getting to a section that you need to know backwards and forwards. The anatomical terminology is not going to just help you in chapter 1. It's going to help you in all the other chapters where we learn anatomy. It's going to help you learn the bones and the muscles and the nerves and the blood vessels. It's going to help you with all the terminology in the rest of this course. Some of you may have taken, this is not a requirement, but some of you may have actually taken a medical terminology course. And that if you have that's about what this is. This whole section is medical terminology. So let's talk about the anatomical position first, and I'm going to flip to this. Know these figures. You just need to find a way to study these figures. You need to know every term, and I would say, I know a lot of students are going to ask me this, probably learn the word in bold. So let's just start with the head region. Okay, the entire head region is called the cephalic region. So learn the word in bold that it's called the cephalon, but also understand in parentheses that it is the cephalic region, because that tends to be the way that I ask it on your exams when you have to match the terms with. So first, let's talk about anatomical position. Notice how the man here is standing. He's standing straight up, his face forward, and his palms are turned to where they're facing outward, and the thumbs are pointing laterally. They're pointing away from the body, okay? So that is the anatomical position. And when we look at the person facing forward, we say that that is the supine position. Or say if a person is lying on their back, that's supine. And then if a person is lying face down on their stomach, we say that's prone. Or if they're turned around and we're looking at their back, that's the prone position. So supine is face up and prone is face down when you're lying down in the anatomical position. Since they're standing up, we wouldn't use those terms. But if they were lying down, then the man on the left in figure A is going to be supine, and the one on the right is going to be prone. But we do need to go through these terms. Okay, so I'm going to start with the cephalic region, the whole entire head, the cephalic region. And the way that I say these is what I'm going to expect you to know. So instead of making it confusing, I'm just going to call these structures by region. Like I'll say cephalic region or facial region, for example. So first you need to know that the cephalic region is the entire head, because cephalic means toward the head. And then the head is divided into the cranium or the skull, the cranial region, and then the facial region. Okay, then let's go down on the left side of the figure. The mouth is the oral region. The chin is the mental region. The armpit is the axillary region. The arm, which is what we call the upper arm in anatomy, that is the arm, is the brachial region. And then the bend of the elbow is called the antecubital region. The forearm is the antebrachial region. The wrist is the carpal region. The palm of the hand is the palmar region. The thumb, we just call that the pollex. We don't call it a region or anything. We just call it the pollex. The thumb is the pollex. The fingers are digits or phalanges, and so we call this whole region where the fingers are, we call that the phalangeal region. Then let's move down the leg. We have the knee, which is the patellar region. The shin, which is the crural region. Crural, hard to say, but crural, C-R-U-R-A-L, crural region is the shin. And again, whereas in anatomy, we say that the brachial region is the arm, that's the upper arm. In anatomy, the leg is actually the lower leg. The crural region is actually what we call the leg, okay? The ankle region is the tarsal region. And then we have the phalangeal region again. The toes and the fingers are all digits or phalanges, so we just say phalangeal region. And the big toe is called the hallux.